Welcome back everybody. This time I am going to talk about uh, join method and section method of truss. So join method and section method. Now I know that join method is a very easy method, but it is time consuming sometimes. Section method is very effective for like complex tracks, or to jump to a member. Let us see one example. Say this is a truss, very simple truss. Let us assume some force here, 2 kV here, 6 kV here, say 2 kV. And the dimension is given, and this is 3 feet, 3 feet. And here to here, 1, 2, 3, 4. Say 4 at the rate of 3 feet equals 12 feet. Yes. And all the joints are pin connected. If the joints are pin connected and force are only at the joint, then it will be truss. Otherwise no. Otherwise it will be frame. So this is a truss. Now if the question asks what is the member force, say in this diagonal. Now, if we consider the joint method means we can consider any joint, draw the free body diagram and find it. So if I, for this member, I will have to draw this joint or this joint. So if I take this joint, it is similar to this, one member here, other member here, and this is the member force I need. And if I draw the x-axis and y-axis, then you can see here my unknown is this force I do not know, this force I do not know, this force I do not know. So it's very difficult if I use joint method. If I use section method, maybe it is very easy. Let us try. What is section method? Section method is we can cut anywhere in the truss in a way that will help us actually. Cutting doesn't mean that you got a truss, you start cutting. No, not like this. You have to cut in a way that it will help you. Now, okay, deleting this part, make it clean. So you can see here for this member, joint method is pretty difficult. 1, 2, 3, 4, 4 unknown. So I will have to start from the beginning. Solve this one first, then this one, then this one, then this one. I might need to do several operations. But section method very shortcut. Okay, let me try. So if I now you can cut anywhere, anyway. I write this way. You can cut anywhere, anyway. Like this way, you can cut many different ways. But you should see whatever cut will help you to that one. So if I can see that if I cut say here, if I cut here, that means this way. I can delete this part. If I cut here and apply summation of fx, then this way, 1 unknown, 2 unknown, 3 unknown, it will not help me. So assume the force, this is my force. If I apply summation of fy, this unknown, this unknown. But if I take moment here, if I take moment here, I do not need to worry about my reaction here. If I take moment here. So that will even, this force will vanish because it is going through this point. Moment equals force time distance. Moment equals force time distance. The moment produced by this force is 0 because it is going through this point. Similarly, moment produced by this force is 0. So I have only one unknown. See, it is very simple. Okay, this member is inclined, so I need the slope. If you saw, I already deleted, but I can recover the dimension. I assumed this part, it is 3 feet, and every bay was 3 feet. That means the slope is 1, 1. So the slope of this line was 3, 3, or if I cut it to 1, 1, make it simple. 1, 1. Then this will be square root 1 square equals square root 2. So simply my hypotenuse is square root 2. Okay, then I will apply moment here. Let me make some space. So I am applying moment here. My first force is obviously this force reaction, and it will vanish because it is going through this point. Distance is 0. This force will vanish. My first force is then 2. So 2 keep, and distance I assume 3 feet. So 3 feet. Now I can assume clockwise moment is positive or counterclockwise moment is positive. Say okay, first I do summation of moment at where? Here. What is the name of this? I did not give any name. Okay, right. At here is 0. Moment at this point is 0. So first force is 2 times 3. So this distance is 3 feet. My second force is this force. It will vanish because it is going through the same point, no moment. Then this force vanish because it is going to the same point. Third force is this. Now it is inclined, so it has 2 components. So one component will work this way, one component will work this way. Let us consider this part first. What is this part? This part. Now first, is it positive or negative? I assumed clockwise. Where to write? I assumed clockwise moment is positive, because for this one I wrote positive. Okay, so this force about this point, it is going through this point, so it will give me clockwise moment. So it is positive. What is the value of this force? What is the rule? Force divided by hypotenuse. Force divided by hypotenuse times the corresponding side. Corresponding. I am taking horizontal part, so my side is 1. I will consider this horizontal part. So 1. That is my force along this way. What is my distance? Distance is obviously this distance, perpendicular distance. Moment is force times perpendicular distance. So this is my distance, that is 3 feet. Then my next force is this component. What is that? That is positive or negative. So it is about this point, it is acting this way. So clockwise. So it is also positive. What is that force? For diagonal divided by hypotenuse times corresponding side. My corresponding side this time is 1. What is the distance? This distance 3. 0. So you can see here only unknown is f. Now if you solve it, you will get the answer. And as everything is positive, that means you will get f as a negative. So the diagonals will carry negative or compression load. So you can see here how easy the section method is compared to joint method. Now, not always. Sometimes joint method is very easy. Let us see another example. Oh, maybe some more discussion here. If I'm not, let me draw the truss again. I forgot the load I assumed. Let me recover. Maybe I assume this is 2 keeps, this is 6 keep, this one is 2 keeps, I think, whatever it is, that doesn't matter. And the distance was given 3 feet, 3 feet, and here everything is 3 feet. Last time I solved for this member. What about for this member? It is similar, yeah? Similar, but we may need to change my cut or the movement point. Okay, if I cut for this member, say if I cut here and take moment here, what will happen? Delete. Before deleting, if I cut here, take moment here, but I need to find my reaction. Okay, let me delete it. So before deleting, you should find your reaction. Okay, without any calculation, we can find the reaction. This truss is symmetric. This way, load is also symmetric. So, okay, solve it. Symmetric, so we can see that if it is symmetric, 50% load will go this way, 50% here. So 2, 6, 2, 10. Here I will get 5. No horizontal force, so I will get it 0. But it is not a good idea to just visually always. We can solve this, yes. So assume this is A, Y, this is AX. If I take moment here, so this is B. So summation of moment at B equals 0. Assume clockwise moment positive. Like this assumption, it has actually no value. No value means you can assume this way positive, you can assume that way positive. Okay, if I take moment here, my first force is 2 keeps. So red is not a good color for this. My first force is 2 keeps. Distance, I assume everything is 3, 3, 3. So 3 feet. About this point, it is going counterclockwise, so minus. Then for this one, again, that will go counterclockwise. So minus 6 keep times 6 feet. This is 6. Then 2 keep, again minus 2 keep, 3, 3, 3, 9 feet. Then this will give clockwise moment. So plus AY times 12 feet equals 0. Okay, if I solve it, I do not have any calculator, but I can try. 3 times 2, 6, 36 is 42, 9 times 2 is 18, so 60 divided by 12. So I will get AY is 5. So my initial visualization is correct. So AY is 5. So once now no horizontal force, so obviously it is 0. Now I can cut here. So cut here means okay, I have a force here, force here, force here. This force I need to find. Now if I take moment here, all this force will vanish. Vanish means the moment will vanish. Okay, now what is the slope of this line? I forgot the dimension. Oh, it was 3, 3, 3, 3. 12, height was 6. Right? Yes. So if it is 6, it was 2. Total was 12. So up to this was 6. So 6, 6. Or simply I can write here 1, 1. So obviously hypotenuse is square root 2. Now I can take moment here. No other unknown. Only the reaction was unknown, but we already solved it. Okay, name this name actually doesn't matter, but if I will give a name, say C. So summation of moment at C equals 0. As you may sign, you will assume clockwise positive or counterclockwise positive, up to you. Say we are used to taking clockwise positive. Okay, my first force 6, it will vanish because distance is 0. This will vanish, distance is 0. So forget this force, this one. 2 keep times 3 feet. We know it is 3 feet. So 3 feet. Clockwise or anti-clockwise, about this point, counterclockwise, so minus. My next force is AY. It will give me clockwise, so positive. AY I got 5 keep. I do not know whether you can see it properly or no. Okay, right below it. So AY is 5 times 3, 6 feet. Then my next force is this force. Name this F1. So it is inclined. That means it has a 2 component. So one component is this way, other is this way. So first consider this one. So about this point, this will give clockwise, so positive. What is the value of the force? Divided by hypotenuse times corresponding. I am taking vertical, so this is my vertical side. 1. What is the distance? This distance. Again, not the inclined distance. Not this distance. No. This distance. I am taking this force. My distance is this perpendicular distance. So 3 feet. Luckily, oh no, this distance, this is not same. Or luckily it might be same, but do not consider this. Then I will consider this force. What is that? F1 divided by hypotenuse times 1 corresponding side, because 1 corresponding side, the distance, this distance. This distance means here to here. Luckily it is the same, 3 feet. Any other force? No. So summation of 0. Now we can see the only one known. If we solve it, you will get it. Okay. Now I will go to so far what we saw. If problem asked about the diagonal, try to take moment at the end. If the member is in the upper side, try to take moment in the lower side. Okay. Try again. So this is my truss. Make it short. If the question asks what is the member force here, what is my suggestion? Cut here, take moment here. Why? See it. If I cut here, so this question is asking what is the member force here. This is my question. So if I take moment here, what is the benefit? Benefit is this force will vanish, this force will vanish. So if I know my reaction 5 keeps and my horizontal reaction 0 and my force here is 2 keeps, you can see that if I take moment here, this force is vanished. I do not need it. If I know it good, similar for this force. This force is vanished because it will produce no moment. So only unknown is this force. So it will be very simple. If I take moment here about this point, this will vanish. So 5 this force times my this distance, that was 3. Positive or negative, say as a clockwise positive, so this way, and this force counterclockwise negative, so F times 3. So actually this F equals 5. If I am not wrong, did I miss anything? No. So this, if the problem asks what is the member force in the diagonal, take moment here. If the question asks what is the member force here, cut here, take moment here. If the question asks what is the member force here, cut straight, take member force here. And this kind of truss is very common. So this kind of question is also very common. Let me quickly tell you other example similar for say signboard type truss. So make it short. Say I have some force here, some force here. If the question asks what is the member force here, joint method might be difficult. Simply cut here, take moment here. How it will be equal? You can see here. If you cut here and take moment here, force here, it will have no effect, no moment. You can find this one very easily. Now if the question asks about this side, take moment other side. Okay, what is that? Say this is my truss. I forgot what I assume. Okay, assume this one. My truss was similar to this. I have force here, force here. If the question asks what is the member force in this side, I told if the question asks the member force in this side, take moment on the other side. So I will try to take moment either here or here. Think a little bit. If I cut here, take moment here. Very easy. So this force will have no effect. So this force no effect, this force no effect. You will find this force only if you know this. So you don't need to worry about this. Easily in a single action you can find the member force here. So for this kind